continuing kind of where we left off, right? We had all those steps from yesterday. Yesterday, we added the step combine like terms. And then we were doing like undoing addition and subtraction, and then undoing multiplication and division. Basically, our backwards GEMDAS, which is SADMEG. That's what we did yesterday. The only new thing that I'm going to add on to this today is a potential first step that we have to do before all of this. And that just simply is to distribute. So if we see a number like a times 3a plus 2, I guess I probably should have not done an a here. If I see something like this, then that's telling me I need to distribute, right? So that's all we're doing. So if I look at number 1, or example 1, letter A, the first step that I have to take care of is to distribute that 3. 3 times x gives me 3x. 3 times negative 2 gives me negative 6. And everything else drops down. That's the only difference today. From here, I can just solve this like any other two-step equation. Plus 6 on both sides. Divide by 3 on both sides to get 9 equals x. Not rocket science. We're okay with that. Fractions, same deal. If I have 1/2, I always think about fractions as the word of. So 1/2 of 4x is 2x. 1/2 of negative 6 is negative 3. Drop that 11 down. Same deal. 2x equals 14. Divide by 2. X equals 7. Right? We got it? Okay. I'm not seeing any disagreement, so I'm going to keep going. Letter C, same idea, maybe looks a little bit different. What's that imaginary number that we can't see in the front but is actually there? Read. It's a 1. So I'm going to treat this just like I'm distributing a negative 1 to the 3k. So that's negative 3k. A negative 1 to the negative 12. 2 negatives is always going to make me a positive. Drop the 48 down. Undo addition and subtraction. Undo multiplication and division. K equals negative 12. I'm not throwing anything crazy at you yet. Letter D might get a little bit trickier, but hopefully not too bad. Our very first step, before we can do anything else here, we have to distribute. I can drop anything else down. So I'm going to drop that negative 6x down. One thing I do want to point out here is that I'm not just distributing a 4, I'm distributing negative 4. So when I start multiplying things and whatnot, I have to be multiplying by that entire thing. So negative 4 times a negative 2x, 2 negatives gives me a positive 8x. And then a negative 4 times a positive 10 gives me negative 40. Please, please, please do not drop your negatives as we are doing these. We have to make sure that negative comes with us the whole time. From here, we can combine our like terms. Do we see the 2 like terms in this problem? They have the same variable with the same exponent. I'm going to combine the coefficients negative 6 and 8 to get 2. And then the variable x stays the same. And that's literally the only difference, is that we had to distribute and then combine like terms. From here, I'm still going to add 40. And then 2x equals negative 16. Divide everything by 2. X equals negative 8. Am I going too fast? Or is this like we got it? Okay. All right, do A and B, and then I'll take 2 people to write it on the board surface thing. Anybody want to give it? Oh, we got it over here. You guys locked in? Who wants to do A? Who wants to do B?
I can do B. Is this right?
Yeah, it looks right.
This is this right? Yeah, I got -2. You got -2.
But what are you talking
Oh,
about?
no, yeah, you're right. It's -3. It's 18 divided by 6. Did you get -3 for me too? I didn't do that one yet. Shoot.
Perfect.
I don't know why
Pass
it's
it
so
over. You can scroll with 2 fingers if you scroll over.
I'll make an extra one. Only if it's,
Perfect. All right, there's these two. Any questions on these guys? We're going to real quickly go through example 3 here, which is our word problem. Today we're going to Chick-fil-A. All right, Noah ate Chick-fil-A 4 times in a row. Each time he ordered the 3-count chicken tenders and an order of regular waffle fries. Waffle fries cost $1.89. He spent a total of $23.92 over the 4 days. How much are the 3-count chicken tenders? Step number 1. We cannot forget this step. Define a variable. What don't we know in this problem? Perfect. Let's call it T, and that's the cost of some tenders. What do I always tell you we should look for first? The what? The total. Our total here is $23.92. So I'm going to use that to be one side of our equal sign. So I have $23.92 equals. What do I know in this problem? Jaden.
3C or 3T.
No, sorry. The T is the cost of the 3-piece tender meal. So that's the whole meal cost. Autumn? He gets the waffle fries for $1.89 4 times. What else does he get 4 times? Tenders, right? And the cost of the tenders is what? T. So I want to represent that he got the tenders and the waffle fries 4 times. How do I represent that he got it 4 times? Just multiply it by 4, right? So I'm going to put this in parentheses. I'm going to put a 4 in the front. There's my equation. This says he spent $23.92, and that's 4 times he went and got however much the chicken tenders cost plus the waffle fries for $1.89. So we're going to distribute. 4 times T is 4T. 4 times 189 is 756. Do some subtraction here to get 1636 equals 4T. Divide by 4. I'm going to make it fit in here. T is 409. So the chicken tender 3-piece thing is $4.09. Any questions on that?